Now is it audible, class? Are you able to hear?
Yes, ma'am.
Okay, class. So let us start with this escape velocity. Wherever I'm not audible to you, please let me know, class, because it can happen that you may be having some difficulties in hearing in the audio because today there's a lot of internet issue. Okay, class. So now escape velocity is what? Escape velocity is the velocity that is required. See, suppose this is Earth. So from the Earth, one body is there. This body has to escape all the gravitational forces of the Earth. So all the forces of the gravitational forces are escaped. It means there is some velocity. There is some velocity that will be required to overcome this force of attraction. Fine. So that minimum velocity with which the body escapes or projects, and the body will stop exactly at infinity only. Body will move infinity only. So this velocity, with the help of which overcomes the gravitational force of Earth and reaches infinity. Because no force is there to stop the body in between. If another force is there, then we'll have the body stop. So this is what? This is the minimum velocity, minimum velocity with which is projected so that it just escapes gravitational pull of Earth. Gravitational pull. Remember this fact because this is. Now see one value you have to remember, class, that is the value of escape velocity of Earth. So value of escape velocity of Earth is 11.2 kilometers. This value, please remember, 11.2 kilometers kilometer per second. This value will not be mentioned to you in the exam and it can be asked to you. So escape velocity of Earth. We escape of Earth. This is 11.2 kilometer per second. This is the value of it. Now, if you want to find out the formula for it, how to derive it, formula is very easy. You will be getting one more velocity. So be clear. If you're having any doubts in between, let me know. Now see, same derivation we'll do, but see one difference that will come. Same derivation that we did for energy. We reached that step, remember, where we integrated g, m, then small m was there by x square dx. Again, here also the changes will be in limits only. See, when we did gravitational potential, that time we took 2 points, right? When we did gravitational potential energy, we took 1 point as infinity. Now what is happening? Now from in gravitational potential energy, the body came from the infinity point to a particular point. Now what is happening? It is escaping and going to infinity. It means from the body's radius, body Earth, from the Earth, the body is moving and escaping into infinity. It means Earth was there, body was kept, now body is moving to infinity. It means initially it is at a separation of R. So you are extending it from R to infinity. So from R to infinity, you will be extending it. This is the difference. Now you can easily figure it out. These steps we did it. This is just the difference that will arise. So see, from here, if you take common work done, G, capital M, small m, minus in fact becomes no, because of 1 by x, and we are left with 1 by x. Limits are from capital R to infinity. So we'll be writing instead of first upper limit, we'll write infinity, then we'll write 1 by R. So it will be just positive of the gravitational potential, G m m by R. This is the value. Now see, work done will be converted into kinetic energy this time, not potential energy. And what is the basic formula of kinetic energy? Yes, class. Formula of kinetic energy. Kinetics energy's formula in terms of mass and velocity.
Half mv square.
Half mv square, right? So only Terim knows this. Half mv square is the velocity, kinetic energy. So that will be half mv square. V will be here the escape velocity, because the velocity here is the escape velocity. So now equate both of it, work done, and this kinetic energy. Equate both of these two equations, because you know kinetic energy will be equal to the work done. So when you equate it over here, G, capital M, small m by R becomes equal to half m V escape square. See class, this small m, small m. Small m means small m is the mass of body. So mass of body gets cancelled. Capital M is mass of Earth. So what is the formula you're getting? VE is under root 2 GM by R. 2 GM by R. This is the formula for it. Fine, 2 under root 2 GM by R. Even one more formula is there. Let me tell you. Till here is it clear to all of you? I'll just tell one more formula that we use for this only before going to the numericals. Clear? Yes, no? Jania? Abdullah? Safura?
Yes, ma'am.
Fine. Now see here, class. If I multiply and divide it by R within the bracket, no, let me. See, escape velocity is 2 GM by R under root, right? So here what I'm doing, I am multiplying and dividing it by R. That won't make any difference. Now, if I multiply and divide it by R, this will become 2 GM R by R square. Now see class from here. GM by capital R square. Can you recall what was capital G into M by R square, this term? What was this term? Capital G into capital M by R square.
Gravitation, like gravitation due to acceleration. Like small g.
Yes, acceleration due to gravity. Correct. Small g. Perfect. Small g is the answer. Others, did you understand or not? Talha, Waziha, Yusuf, did you recall this?
Yes, ma'am.
Okay. Now, see, so one more formula in the sense is that we can replace this entire term by small g under root r. So if needed, you can use this formula also. Suppose you are given acceleration due to gravity, or you're given radius of some other planet or something that is given. Now, one theory part that comes from this topic is, one question is that how is the question, no, it will do what? It will mention you 3 types of bodies, 3 kg, 4 kg, 5 kg, and compare their escape velocities. When you compare their escape velocities, you will see thus many students answer 5 kg has the higher mass, so it will move slowly, so entire velocity will decrease. No, remember, escape velocity is independent mass of body. Capital M is mass of Earth. For Earth, you're using it. If you know, this is for the planets, not for the body. Just remember this fact. Small m has been cancelled. So it means if small m is not present, it means escape velocity is independent of mass of Earth. So escape velocity is independent of mass of, not Earth, sorry, of the body. Of the body. Fine. It depends on the planet from which the body is projected, because capital M, so capital M is depicting you that it depends on the mass of the planet. And please remember again, this value 11.2 kilometers per second is for Earth. And how is it calculated? If you want, you can calculate it by 2 into acceleration due to gravity of Earth, you know, and radius of Earth also, you know, 6.4 into 10 to the power 6 meters. If you will substitute, you will notice after conversion, you will get the answer as 11.2 kilometers per second. One good important question comes from this in terms of black hole that I'll discuss later. First, you note down all these points, then we'll discuss that. See class, this is a question which says that using the concept of escape velocity, you have to find out the radius of black hole. So see one thing, for black hole escape, no, for black hole's escape velocity of black hole is should be greater than speed of light. When do we say anything can escape black hole? This just requires your basic knowledge of physics. Mainly, anything can exceed black hole if it moves faster than the speed of light. I hope you must have heard of this fact. So if it is greater than speed of light, then only it will be able to escape black hole. So we have to find out that velocity. So just by naming that escape velocity, this is nothing different. It means escape velocity should be greater than speed of light. It means the formula which we are placing, which we have studied, 2gm by r, this should be greater than the speed of light. Now take the square on both the sides. 2gm by r is greater than c square. From here, radius will be less than 2gm by c square. Easy. Just this line you have to remember. Escape velocity should be greater than, this is speed of light, which is 3 into 10 to the power 8 meter per second. Note it down. One more question I'll discuss. If anyone is writing the previous question, please tell me, I'll scroll up. Otherwise, I'm starting with the second question. It says that again, a body is projected with a velocity and that velocity is greater than escape velocity this time. In the last question, escape velocity was greater than the speed of light. In the second question, the body with which is projected is having the velocity v. Now v is greater than the escape velocity. Now you have to calculate the velocity with which it moves at infinity. See class, how to start with this question. Firstly, kinetic energy of the body. With the help of that, you can calculate. Why? Because mass of the body will not change. And if velocity is changing, and the best energy that involves velocity is your kinetic energy. And also kinetic energy with which the body that will be projected from Earth simply. If v is the velocity with which it is projected, so kinetic energy will be half mv square. Simply it will be half mv square. And kinetic energy corresponding to the escape velocity. So kinetic energy for the escape velocity, it will be half mv escape whole square. Right, v escape whole square. This is the escape velocity. This is the velocity with which it was projected. And this ve square, this is the velocity with which it was, this is the escape velocity. Now see, let's take some random, this velocity at infinity. Let's say this velocity at infinity, let's say this is v dash, velocity at infinity. So total change in kinetic energy, this is the initial kinetic energy. This total kinetic, this initial kinetic energy, change in the initial kinetic energy will be equal to this final change in final kinetic energy. Understood? So it means change in this kinetic energy will be half mv square minus half mve square equal to final kinetic energy of this half mv dash whole square. So from here half m will get cancelled. Half m. So we are left with v dash square is equal to v square minus ve whole square. So your v dash will be equal to under root v square minus ve square. So this will be the answer. Note it down. Now we'll start with satellites. Satellites is also a big topic. Now see, regarding satellites, one big question we have to do. that will cover the basics of your satellite. In satellites, not the thing, rest of the things theory part is same. It's just that, see, satellite is just a massive body which revolves around another heavenly body. And why is it able to revolve? Is because of the gravitational pull. Like you have one big body, let's say, or let's take Earth only. Here, let's say you have moon. So moon is revolving around the earth. That's why we call the moon as the natural satellite of earth. So satellite is any massive body which revolves around a heavy body. Due to its gravitational pull. And the satellites are of two types. One is the natural satellite, like the moon. And one are your artificial satellites. Now, the question that I have to discuss, note this down, then I'll discuss the question. Because directly I'll solve it on the figure only. You know that question? That question is simple, very easy. One question was left, so that I have to come. Safura, you're not on the group. I have sent all the note link on the group as well.
Yes, ma'am, I'm not there in the group.
You are?
No, ma'am.
Okay, you're not on the group. Okay, then I'll share the link personally with you then.
Okay, ma'am.
I'll share the links. See here, two bodies are there that are given to you. One is having mass m, another body is having mass 4m. All right, now there's a neutral point in between. Total separation between the bodies from the center is 6r. Let's take it as small r. That entire separation is 6r. From the centers, from this point to this point. Also, radii of both the bodies are same. This is also r, this is also r. You have to find out the final velocity. If an object is released, this is actually part of your escape velocity, is released from this body, then what will be the velocity of it that is needed. So see class, firstly, how to solve these types of questions. You have to just main thing here is find out this neutral point. Let's say suppose this point is x that I've taken. So left point, that is 6r minus x will be left. So now see neutral point, how will I calculate the neutral point? Total intensity will be 0. I1 will be equal to I2. It means gm by x square will be equal to g4m by r minus x whole square. So gm gets cancelled. This becomes 1 by x is equal to 2 by r minus 6. Now from here you have to calculate the neutral point first. See class, we are actually finding out the velocity with which it will move. Now firstly we have to understand where is the neutral point, because at neutral point no gravitational force will exert. All right, that's why we are finding out the neutral point first. So if you solve this, this becomes 6r minus x is equal to 2x. Oh, this is 6r, sorry. So this will become x is 6r by 3. So x is equal to 2r. So 6x is equal to 2r. So at neutral point, no gravitational force exists. So velocity required to throw mass, whatever mass, let's say m, from the first object to second object at the neutral point, you will simply apply conservation of energy. Simple conservation of energy you will apply. Half mv square minus capital G, capital M, small m by r. This is kinetic energy. So half mv square, let's say v is the velocity. So half mv square, initial potential energy. So first C class, this potential energy it will be having because this body is kept on the surface of Earth. So there will be potential energy between these two, right? And one potential energy will exist between this and this. This potential energy will also exist. It means this separation, subtract r from 6r. So if you subtract r from 6r, you get the separation as 5r, right? And here the separation from this body is r only. So now see how will you write it. Initial kinetic energy half mv square minus gmm by r, and one more additional g 4m into small m by 5r. This is equal to, now final velocity will obviously be 0 at infinity, minus gmm by 2r minus g4m small m by this will be how much? 6r minus 2r, so 4r. See how I have written these potential energies. When the objects have, when the body has reached, or it is final energy you are calculating, right? You're calculating the final energy. So add from the neutral point, we are calculating it. 6r minus 2r. Now at this neutral point, we are calculating rest of the things. So gmm by 2r. Firstly, this separation from this body at the neutral point, we are calculating. This was our initial point. Class, this was the initial point. This is the final point right now. Because at neutral point only, the gravitational force will not be 0. So if you place the body M, this separation will be 2r because this is x and x was 2r. And this separation will be 4r. Don't go by the diagram. In diagram, this neutral point had to be located near the body of mass capital M. Fine. So now when you apply these forces, these values, This comes out to be this much, minus gmm by 2r and minus g 4mm by 4r. Now from here, you just have to find out the value of velocity. This was what was asked to you. One more thing, before we start with orbital velocity, satellites I was discussing with you. In satellites, one more thing can be asked, what is the principle of launching satellite? So always remember, orbital velocity is a concept that we are going to discuss right now. With the help of orbital velocity, it will keep on moving. See, escape velocity helped the satellite to move away, to escape the gravitational pull of Earth. And orbital velocity allowed it to revolve it. So if by chance it is asked to you in your paper, principle of launching satellite, principle of launching satellite. So satellite when projected with orbital velocity, satellite when projected, when the satellite is projected with orbital velocity, when it is projected with orbital velocity, I'll discuss it with you after this. When it is projected with orbital velocity, then it revolves around the Earth in stable orbit. Then it revolves around Earth in stable orbit. Fine. Now, what is orbital velocity? I'll just discuss it with you. Orbital velocity is simple, like escape velocity was. No, similar formula, just don't get confused with it. This you have written. From here, note it down. I'll discuss orbital velocity with you. All those who get the value of this velocity, please share it with me, whatever values of velocity you're getting. So class, from the term only you can conclude this. Escape velocity was what? Escaping the gravitational pull of Earth. You escaped a body from the gravity, Earth's gravity, or for any other planet's gravitational pull. Now the next topic that you have, this is orbital velocity. Orbital velocity means orbiting. Now your satellite is able to revolve around Earth. That is known as orbital velocity. Velocity with which satellite revolves around the Earth. So velocity with which satellite revolves around the Earth. This is known as orbital velocity. Let's say you have Earth. So Earth is there and then the orbit of Earth is there. Now see, here at the center you have Earth, and let's say this is the satellite of Earth. So Earth's radius is this, and separation between the Earth's radius and this satellite, this is h. So this entire distance, this becomes h plus r, which we can write it as small r plus h. Now see, centripetal force, that is necessary centripetal force, that will be fulfilled by the gravitational force. Remember, when we were discussing centripetal force, that time also I had told you that centripetal force is not a force. It is a requirement that is fulfilled by other forces. Like if you have two charges are revolving, then that necessary centripetal force will be provided by the electrostatic force. If a body is revolving around a planet, and that is held through gravitational force, so this gravitational force will provide the necessary centripetal force. So we can say centripetal force is equal to gravitational force in this case. Formula of centripetal force is mv square by r, and here gravitational force, if we apply, see, capital G, m1, 1 is mass of Earth, m2, mass of the body, divided by r square. So r, this cancels the square, v square, and this small m also gets cancelled, no? So g m by r. So velocity, orbital velocity will be capital G m by r. What was the difference? Difference is there was a 2 that occurred in escape velocity. Also, this r's meaning is different. This r is not just the radius of Earth. This is not just the radius of Earth. This is now radius of Earth plus this separation. This is the orbital velocity. Even if we want to write it in terms of acceleration due to gravity, we'll multiply this entire term by r. Or let's do one thing. Since r is not there, let's multiply and it divided by r square. So now class, this term g m by r square, this will again be acceleration due to gravity. If this term is acceleration due to gravity, this will be g r square by r plus h under root. So this is also one more formula that you can use for orbital velocity. And this velocity is your orbital velocity. Fine. Now, the way we had 11.2 kilometer per second as the escape velocity of Earth. So if you put in the data, capital G by under root capital G into m by r is the formula, no? Under root gm by r. So we know the gravitational constant, we know the mass of Earth, we know the radius of Earth. If we substitute in all the terms, in this term, no, capital G m by r, in this term, if we substitute all the values for Earth, this will come around 8.9 kilometer per second. This is the orbital velocity of a satellite that is revolving closer to the Earth. So from this, you can calculate many things. Many things you can calculate. Time, velocity, height, energy, and questions come from that part also. Noted till here, then these topics which I have told you: time, period, velocity. Velocity is their time, period, height. All these we'll calculate. Any doubts you have, class, ask me. Now class C, formula of time period can be calculated using velocity only. You know velocity and you know the distance that is required to cover one revolution. What according to you should be the distance? Yes class, according to you. Answer me in the chat column. This is the satellite. Here at the center you have Earth or some other object. What should be the distance? Yes, answers class, otherwise I'll start calling out names. Whatever you think, answer. I'll correct you. What do you think is the distance when one person takes to cover a circle? Class, this way it will not work. If you're answering, otherwise I'll ask you all to open up your cameras in the next class. Kareem, you were answering?
Ma'am, would it be 2 pi?
2
Like
pi
you
r.
said.
Exactly, circumference of a circle. It will be 2 pi r only. So velocity will be distance covered by time. Distance will be 2 pi r. Time will be capital T. And orbital's velocity is formula from here we'll put in here. That will make capital T as 2 pi r divided by orbital velocity. And orbital velocity is under root g m by small r. Or you can write time period as 2 pi r by gm, like this. Now see, here if we want to keep everything within the brackets, otherwise this formula is also fine, but to keep everything within the brackets, we have to put in the squares of this, no? So it will become 2 pi r square into r by gm. So see, formula of time period. Time period will be 4 pi square r cube by g into m. This is the formula of time period. Now you can keep the value of small r. So 4 pi r square r plus h whole cube by gm. This formula. All right. Now, even if you want to calculate the height, you can calculate the height of it using this from here. Using this formula only, no, of time period. You can calculate it. See, if you square both the terms, you will get t square is equal to 4 pi square r plus h whole cube divided by gm. So from here, r plus h whole cube will be gmt square divided by 4 pi square. And if you want to calculate value, or just value of r plus h will be, see, gmt square by 4 pi square, and this entire term to the power 1 by 3. So from here, if you want to find out the value of h will be just the subtraction of r into this term. So height will be gmt square by 4 pi square to the power 1 by 3 minus r. This is the formula for height. This is the height. So height, time period. Then we have energies also to be calculated. See, energy will be what? Kinetic potential energy. If you write, potential energy is G m1 m2 by r. So here also, if you write potential energy, that will be minus G capital M small m by r. Or you can write this capital G small m into capital M divided by r plus h. This way. Or kinetic energy. Kinetic energy will be half mv square, and value of v is, see, v was gm by r. So v square will be, it will just be gm by r. So keep it here. So kinetic energy will be half m into gm by r. That is G capital M into small m by 2r. And if you have to calculate the value of total energy can be also asked, or mechanical energy. So mechanical energy is the sum of kinetic energy and potential energy. So mechanical energy will be kinetic energy plus potential energy. So that will be capital M small m G 2r, and this will be minus capital G capital M by small r. So when you solve it, you will get minus capital M small m by 2. So it is basically negative of kinetic energy. The total energy or mechanical energy is negative of kinetic energy. This is the total energy. So kinetic energy, potential energy, total energy, all these will be calculated. Note it. If you will complete till here, you can leave. Now rest of the portion we'll complete in the next class only.